Hi guys, how's it going? I'm Alejandro, the CGI nerd, and today what I'm going to be doing is working on creating a script that will automate the process of creating a tree. Later on we can expand it so that we can populate random trees on a surface, but I want to create a tree generator for a specific stylized tree. I'm doing a stylized tree just so that way it's kind of quick and easy, but the same concepts apply for a more complicated tree. So the thing that we want to start off with is figuring out how we're going to do this. So I know basically I'm going to start off by creating a cube, but I want to make this a bit flexible. So I'm going to start off by importing Maya.cmds as MC. Okay, so I'm going to start off by creating a UI for the tool. I don't know exactly all the attributes that I want to have on it yet, but I do know that I want to have a UI to be able to control things. So I'm going to define a function here that is called AP tree gen tool. So AP is just my initials. And then I am going to do if MC.window, and then we can think of a name for this window. I'm just going to call it this, but add win to the end, so that way we know it's window and it's staying all consistent with the same tool. Exist equals true. So we're checking if this window exists. We are going to delete it. So it's going to be mc.delete UI. And we have to tell it which one we want to delete. So I am going to take this name here and put it there. And it's going to delete that window. Now we go through the process of actually creating the window. This is just a catch, just in case the window already exists. It deletes it first before recreating it. So that way we don't have multiple of the same window showing up. So mc.window, and we can call it that. I'm not going to add any settings yet. If I want to make it more functional, I can do that later. And then let's just do mc.window, or sorry, show window. So if we run this, actually right now there won't be anything that pops up, but we can run the function and then it will work. And it popped it up on a different window, but here is my window as it stands right now. And if I run this over and over, it won't create multiple windows on top of each other, and you guys can't see my second window, but there's none on my second monitor either. Okay. So now we need to add something in here so that we can interact with. And at first what I'm going to do is make it functional. So I'm going to kind of make it a functional tool. So I'm just going to add everything down into a column layout. But if in the future, I might go in and make it kind of more user-friendly, the UI itself. So I'm going to create a column layout, and inside of that column layout, I want to put a float slider group. It's the L, float slider group. And what that does is it gives us a slider here that we can manipulate, but instead of doing just the float slider group actually gives us a little bit more functionality. So if we go in here and we type in, let's give this a name. So this is going to be my trunk height slider. And we can create a label. So right now with just this, if we run it, it looks exactly the same. But we can add a label. And give it a string. And I'm going to call this trunk height. So now we can see that we have a label ahead of it, so that way we can actually see what the slider is controlling. Another thing that is pretty cool that I actually like with these sliders, because a lot of times I like to see the values themselves. So what I'll do is add a field. And we just have to tell it field equals true. And we get a numeric value here. And by default it goes from 0 to 100. So with this one, I've experimented a little bit, and with the size tree that I want it between 1 to 5 units. So we can actually set, actually 1 to 10 units, sorry. So we can set a value for the minimum value. And that is going to be equal to, excuse me, 1, like I said. And then we're going to have our max value, which is equal to 10. And then let's just run this really quick. And you can see now when I go to the slider, it goes 10 and 1. But by default, when we create this tool, it's a little weird. It actually defaults to 0 because that's the default value there, even though we can't assign 0. So let's add a value by default. So I'm going to put a dot here, or a comma, and then I'm going to say value is equal to 5. So that way I have a default value that is in the range between 1 to 10. And then this actually, I don't see if we try to put -1. Nope, it doesn't. If we try to put 20, the most it lets us go is into 10. You can do this a little bit different where the slider has a range, but then you can go over it. But for my tool, I want to completely control the min and max of what is possible to happen with this tool. Alright, so let's create a function here. AP gen, or tree gen. So that way we know that this is the function that creates the tree. Right now I don't have anything going on in it, so I'm just going to put pass, so that way we can actually run the function and it won't be any issue. When I open up the tree, I do want to be able to have a, oops, I don't need any of that. I do want to be able to have the tree in the environment right away. I don't want to have to like push any buttons over here, but then I can actually control the tree here. Alright, so to do that, I'm going to actually run the function after I've called it. And actually, I should call all the functions after I've defined everything. So I'm going to put that one there, and then I'm going to say AP tree gen. So this is a little strange because it's going to create basically the tool that we're using to control it, but it's also going to create a default tree over here. But that's just so that we can have the ability to control it right away and see what is actually being created. Okay, with this long line here, I'm going to add, I believe it's called DC for drag command is equal to, and then we need to put the value of this function that we're going to be calling. So as we adjust the sliders, I want to be able to run this function so that we can see how the tree updates. And error flag invalid argument for flag DC. Okay, it has to be a string. I'm sorry, can't just be the command itself. And DC stands for drag command. There we go, and it popped it up on my other window, but here is the tool. So now every time I drag this, it is changing. Actually, let me show you this so that you can see. I'll say print tree is, or we'll just say tree made. There you go. So we'll run this, and you'll see as I slide, it's running that function over and over. Let me clear the history up here. The thing that you'll want to worry about a little bit is that if I type in a value here, you'll see that the command was not actually ran, but if I click on the slider, it does run. So even though I've set the tree, or the drag command, so that it changes as we're dragging it, we also want to do the change command. Let me show you what happens if we have just change command. Let me do the history. So here, it's not changing at all until I let it go. As soon as I let it go, it runs the command, and over here we can do a value, and if we change it, it does run the command as well. So I want to actually do both. So I'm going to have DC here for drag command, and since it's so similar, I'm just going to copy everything, comma, paste that in, and I'm going to put change command. So now if we type in a value, let's say I wanted to make a size 10, it does do that, and then if I drag it, it does run the tree generator so that we can see that the tree is being created and how it's changing. Alright, so let's get this actually doing something, because right now it's not doing anything at all. So I want to try to make this as modular as possible. I kind of did an experiment, and I made it very procedural where it's just kind of top to bottom, but I want to make some modular functions so that we can reuse a lot of the code, because before I was copying and pasting a lot of the stuff that I was doing. So I'm gonna do AP create smooth cube. And I need to create that function. So I'm going to start off with the trunk for the stylized tree with a smooth cube. So I'm going to define this function. Actually, let me define it above this. And we're going to start off with the MC poly cube. So now when we run the command, we can see that it actually creates the cube for us. It's not being controlled at all. So we need to get some feedback from this GUI into these tools. I could add it straight into the smooth cube, but I know that I might need to reuse a lot of the commands in different things, or the attributes in different functions. So anything that I'm getting from the GUI, I'm going to actually query into the tree generator function. So if I wanted to query this, which is the height right now, so I'm going to say trunk height is equal to this, and then we're going to query equals true. And what do we want to query? We want to query the value. So value equals true. Running this, right now it doesn't change anything. We just query the value. But what we can say is add that value here. Trunk height. And then for the create smooth cube, we can say we're using a height value, which is being fed in from this. Let's call this tree trunk, and we'll give it a name that is equal to tree trunk. And then we're going to say the height is equal to height. And just so that's not as confusing, I'm going to call this T height. So it'll be T height. Okay, let's run this. And it is not changing that. Actually, it's creating a whole bunch of cubes here. So let's fix that really quick. Oops. If obj exists, tree trunk MC, oops, and this is, need to add the namespace, mc.objectExist, that'll be MC delete tree trunk. There we go. So as we do this, okay, it is deleting that, but it should create it afterwards. Trunk height, trunk height. Let's see. Is it running? Okay, line 11. Okay, let's not give it a name here. We'll just do the name tree trunk. There we go. Now we fixed that. We can see that it automatically creates the cube at that size. That is great. And then as we change it, it does change the size of the cube, which is exactly what we want. With the trees, I like it to be right on top of the origin. So let's go in and adjust the position. It's going to be MC, not there, MC.setAtter. The attribute we want to change is tree trunk dot ty, is translate y, and we are going to take it from t height divided by 2, I believe. Let's try that and make sure it works. Yep. And then as we change this, we can say that it always stays on the ground because it is basing it out off of whatever the current height of the cube is, which is perfect for our needs. Okay, so now we want to be able to set the subdivisions on the height. So that way it's not one big shape here. Also, I want to make this a little bit more flexible because right now it's just creating the tree trunk. So I'm going to give it a name here. Let's say that at first we ask for the name trunk. And inside of the create smallest cube, I'm going to actually change this obj height because it's not always going to be the trunk. And then at the beginning, I have to put obj name, and then I'm going to replace these. Here and here I'm going to have to concatenate it, so it's going to be obj name plus ty. And let's make sure that everything works. Yep. And it might look like it's jumping a little bit, and that's because it needs to calculate everything as we go in. But when I'm not recording the screen at the same time, it actually runs pretty smoothly on my computer. Okay, so we have that all working. And now here we can say subdivision height is equal to obj height. So it should give us pretty square says invalid flag. Let's see, I probably misspelled it. Just gonna copy paste over here. Yeah, I misspelled height. There we go. So we can see as it grows, it keeps the subdivisions pretty uniform, and as it gets smaller, it doesn't get any smaller overall. or it doesn't squish the geometry, which is pretty nice. Okay, so that allows us to create the height and the subdivisions for that, and I think that's all for right now that we need to set on that, but we need to manipulate this now as well. I'm going to start off by doing an MC dot poly bevel, and we want to do that to tree, or sorry, not tree trunk, but obj name. So that gives us a beveled surface for our tree, which starts rounding it out for us. I don't particularly like the corners where it creates triangles. But if we do a poly smooth after it as well, so we do MC dot poly smooth obj name, you'll see that we get a much smoother object here. So as we go through, and it's proportional, it's not like if we make it really small, there's a ton of geometry on there. It keeps it the right size it needs to be for that particular size tree trunk. So I like that, and then that also prevents the triangles. So we can see all these corners here, they're now 4-sided faces rather than 3-sided faces. So this will give us the ability to place objects right where we need them. For this, and it places it right on the ground. Later on, when we're creating other objects, we don't necessarily want them to be on the ground, but we can add a different function that will manipulate that. Or I can figure out where I want to place this, because I'm going to be wanting to create another kind of thing on top. I don't know. When we get there, we'll make adjustments as we go. So now I want to add extra functionality, because this is a pretty boring tree trunk. I want to, even though I want it to be kind of smooth and stylized, I also want it to be able to have some kind of quirky styling to it. So we're going to do, oops, was in the wrong window. Let's do it here. Should I add it to this function? Now I'm going to add separate functions. So let's do a function here. So I'm going to do, yeah, that's what I'm going to do. Instead of calling this function here, I'm going to do AP create tree trunk. So that means I'm going to need to define, do I want to do that? Yeah, that's what I'm going to do. define AP tree trunk. And what I am going to call is this inside of the tree trunk. And then I can call other functions inside of here. I do need to pass along the trunk height because it doesn't know what it is. And actually, it doesn't need to, the tree as a whole doesn't need the trunk height. Yeah, it does. Never mind. So as an argument, I can send the trunk height here. And that goes straight into here, which leads it to here and feeds it through the whole thing. So let's make sure that this still works. I did get an error on line 22, global name, tree trunk is not defined. Line 22, AP create tree trunk, AP create tree trunk. There we go. I just called it the tree trunk, so now, there we go. That gives us a little bit more possibilities for what we want to do. AP flare obj. So I'm going to create that function here as well. Define AP flare obj. So the first thing I need is the name of the object I'm going to be manipulating. So we're going to say this is obj name. And I'm doing it in separate functions like this, like I said, so that way in the future I can go in and manipulate what I need to on other objects using these same functions. So I'm trying to create it as flexible as possible. Okay, so now that I have the tree trunk name, I can do a nonlinear deformer. So let's do MC dot, what is it called? It is called nonlinear. Nonlinear. What are we going to apply it to? We're going to apply it to tree, or sorry, obj name. And is there any special attributes? Yeah. What type of nonlinear deformer are we going to be creating? It's going to be a flare. I believe that's, yeah. Flare. And this is one of the issues that I've seen. Let's open up the outliner really quick. One of the issues, let me shrink this window here. One of the issues that I've seen, so let's create this really quick, is here we have flare handle 1 as the name. And I think this is a bug inside of Maya. But inside of this flare, in theory, we should be able to, because in the documentation it says name is equal to, we can give it a name. We can say obj plus, or obj name plus flare but we can see that it doesn't actually change the name. So I could be wrong, but I think that is a bug with Maya, and you can see as we run this that it doesn't actually create an error for us. Double check that we have it here. Yeah, so it doesn't create an error when it's doing this. It's just that for some reason it doesn't accept the name, even though the name flag does exist. So just so that I kind of have it a little bit cleaner, I am going to say rename, and I'm going to take whatever the handle name is. I mean, this is kind of not the way I should be doing this. But I do want to be able to have this functionality in here. I'm going to copy that there and paste it. So now we should see that it's called tree trunk flare now. And over here, you can see that the input, the shape node is changed to tree trunk flare shape. That's fine, but the input are not, and I want to be able to change that. So basically it's called flare 1, and I want to be able to change that object name as well. So that way it matches the tree trunk as well. Flare here, let's go in and I'm going to rename that input node as well. So it's called flare 1, and it is going to be named the flare input. So now when we create it, we should see that the flare input is here. If we click at it, we still get access to everything that we need access to there. Okay. Let's go in, and now we need some inputs so that we can adjust the tree, the flare amount. And basically what I'm going to want to be able to do is on the start, manipulate this, make it the base wider if we wanted to, and also the top thinner and wider. And basically maybe not all the way down to maybe I'll let them go down to 0 if they want to come to a point that would be a little weird, but I'll allow them to do that. Basically the range that the flare does let us do by default from 0 to 10. So what we want for this is basically these commands here. And we're going to do a set adder. And we need extra lines here for new sliders that we will control with it. So I am going to copy this. Oops. And paste it a couple times. So this is going to be trunk top flare and trunk base flare. Fix that. There we go. And then we'll need to change these names as well. Trunk top flare and trunk base flare. And both of these, we know that we want to have a min value of 0 and a max of 10. So the max is 10 already, and then the default value I'm going to leave at 1 instead of upping it to 5. There we go. So now we have these extra controls here. It is not doing anything yet, so we need to tell it to do that, and we need to feed the machine here that we got going. So, trunk height here. Basically going to copy this line here. A couple times, so this is going to be tree top flare or trunk, sorry. Base flare. And actually, these I don't think need to be run. I don't need this information for anything else other than the tree, so I'm not going to have it calculated at this state here. I'm going to call it inside of the tree trunk. We'll need the height for other things, but we don't necessarily need it, the flare, for anything else other than the tree trunk, so I'm going to call it in here. So I need to make sure that I'm calling the right things. Top flare and base flare, and then I'm going to take both of those values, trunk top flare, oh, but not in the smooth, I need it in the object flare. Trunk top flare and base, or trunk base flare. There we go. So in the flare, we can say top flare and bottom or base flare. And maybe since I'm going to be calling this a few times, I'll create a variable for it. I'm going to say handle name call this flare name. There we go. So flare name is equal to that. That makes it better, and then we'll say input name is equal to this. I'm going to say this is input name. There we go. So that way we don't have to type all of that over and over again. So mc.set adder set adder, and we are going to do input name plus, and then it was let's double check this here. The start, which will be the base. Let's do the end first. So, oops, I didn't want to move. I just want to set that value. It is end flare x and end flare z. Dot end flare x, and then we want to change that make sure. Okay, the end flare is the top. So we'll say it's equal to top flare, which is this value here that we get from the input. And then we'll copy this run it again. This time it's going to be Z, and it needs to be a capital Z. And this is going to be also top flare. And then we'll copy both of these. And I am going to say this is start flare. And instead of top flare, we're going to use base flare. So there we go. Now we should be able to control the flare for both the base and the top. Great. Okay, so another thing that I want to do is be able to add a little bit of squash and stretch, so that way there's a little bit of character into the shape of the tree. Hey, how's it going, Gabo Game 666? I hope you're doing well. I am doing really good. I'm just working on this tree generator here. Okay, so let's go on to the next step. I'm going to add a squash and stretch here, so that way I can kind of taper the shape or make it bow out as well. So it's going to be another function, and I need another set of sliders here. I think I want to actually bow it before I do the flare. So let's go into our UI here, and I'm going to copy one of these sliders here. So it's going to be after the height. And this one's going to be trunk, call it squash, And then for the label, I will call it trunk squash stretch. So it looks something like that. I don't know what are the min and max that I want to do. It's probably going to be 1 and -1. So I'll change that value here, and if it is different, I will change it later. And the default value I'm going to make at 0. So I have this, and I can adjust it from 0 to 1. Okay, so with that squash, we're going to make another function, but I'm going to call it here in the tree trunk because I don't need the squash and stretch for anything else down the line. So let's get this query command, and I probably messed that up. Copy, paste, and this is going to be squash and the name is squash. We're going to query the value. Cool. That is great. Let's run this, make sure we don't have any errors. And it doesn't look like we do. Awesome. Okay, so I have the new inputs that we need. I am going to create a function here, and like I said, I want it to happen before the flare. So AP. So on the flare, something that I didn't add at the end of this, because I'm going to do multiple deformers, I want to clear the history. So I'm just going to say mc dot delete all history. So that way, when we run it, you'll see that we end off without seeing the deformer there, but we should be able to see the name. So line 19, what did I miss at line 19? Oops, let's comment this out because I'm working on something there. There we go. So it lets you update this, but it deletes the history so that we're not stacking a whole bunch of modifiers one on top of each other and slowing the tool down. Okay, so this is going to be AP. We're going to do squash obj, and we need to create that function. So let's define AP squash obj, and we are going to need the value of trunk squash, and we are going to need tree trunk as a value as well. Tree trunk. Okay, so we're going to say this is obj name, and then squash mount and And then here we are going to start working with this. So we are going to basically start in a similar fashion. I'll end up looking up what the names are. Actually, it's probably going to be the same thing, but I'll build it as we build out. MC.nonlinear. And with this nonlinear deformer, we are going to apply it to obj name. And the type is going to be equal to squash. And let's see there. Did it create an error? Nope. It deletes the history afterwards, so I can't see the name of the object. I'm going to comment this out really quick so that we can see the squash handle here and see the attributes that we need. Actually, what I am going to do, instead of commenting this out here, since we're working on just the squash right now, I'm going to comment out the whole flare function. So that way we're only working with the squash right now. But the squash is going to give us this here, and we need to be able to manipulate the expand. We can see that the squash name is squash1, and the handle name is that, and we're going to need to manipulate it the same way with the name that we did for the flare, because the nonlinear just doesn't read the name from the inputs. So this is going to be squash, and this is going to be squash input. Let me squish this window a little bit. And basically the attribute that we need to adjust is the factor. So we're going to rename this is going to be basically, instead of flare, squash handle 1, and then this is going to be squash 1. And this is going to be squash name. So we have the name here, and we have the input here. That is great. Now we need to adjust basically the factor in the squash and stretch. So let's go over here, and if we adjust the factor, you can see that it squashes and stretches. So basically I want it to go from -1 to 1. So that should give us quite a bit of variations for our tree. There's going to be some adjustments that we need to make because it is manipulating where the position of the tree is for the base. So what we can do to actually manipulate that is adjust the low bound. So the low bound is always going to be 0. We'll take the high bound and make it 2, and then take the translate y on this shape and make it 0. So you'll see now when we adjust the factor here, we get it to stay on the base as we manipulate it. So that is great. So let's go in and do that in code. So we have the rename. So I want to take set adder, and then the squash name dot ty. We're going to change that to 0. mc dot set adder I am going to change the input name dot low bound. So it is just low bound like that. So input name plus dot low bound, and the low bound is going to be set to 0. I'm going to copy this because it's mostly the same. This is going to be high bound, and that is going to be set to 2. And then this is going to be the factor, and the factor is going to be set to the squash amount. There we go. So now we should be able to squash and stretch this tree, and it stays at the base. And let's uncomment the flare function here. And now we should be able to flare the tree as we want and be able to give it a bit of a squash and stretch as well. So without the stretch, that's kind of what we end up with. And we can even make this taller and then stretch it. You can see kind of how it tapers it, and it makes it a really kind of cool shape where it has a fall off rather than having a complete just straight line from one point to the other. Okay. Now I want to add one more functionality to the trunk where I'm giving it a bit of a bend. So with this, I am going to actually create it down here. because I'm going to bend the whole tree, everything all together. So it should work all as a whole rather than trying to do individual parts. Right now it's just tree trunk, but what I'm going to end up doing is combining all the parts and then calling it just tree. That is using the polyunite command. So in here, what I am going to do is, before I call the bend, I'm just going to call polyunite here, but I might have to add it into a function. MC dot polyunite tree trunk and I don't have anything to unite it with, so I'm just going to give it a name. And it is going to be tree. So that will allow me to add tree to the bend here, and I haven't created this function, so let's create it really quick. And I'll create it right above this, so it's going to be AP or define AP bend tree. I'm going to pass for right now. 55, it needs at least 2 objects. So what I am going to do, let's see, is create a null. Name equals null, and then I will basically merge the null together with it. See if that works. Nope, it does not like that. So what I'm going to do is, instead of uniting that, I am going to, I think I can do this. Let's do a tree grp grp and then I am going to mc.parent tree trunk with tree grp, and in the future line 55. Do I need to put tree trunk here? And then I don't need to parent it. See, there we go. And let me actually delete the history after the squash them out. Line 57. Oh. Name. OBJ name. There we go. And let's see, delete the history here. Sorry, I'm trying to see why I'm getting all these extra nodes being created. Not under file, edit, delete all by type, history. Shouldn't. Oh, I need to make sure that I delete the group too. Actually, now that I have it all grouped together, I think I can just delete tree grp grp, and I'm not getting extra nodes. That's perfect. And let's see if I can assign a bend deformer to a group. Nonlinear bend. Great. And does it work? Oops. Great. Awesome. It works. So obviously right now the bend is kind of doing it a little bit wonky the way I want it, but it's going to be similar to the way we changed the squash and stretch. We're going to put the low bound to 0, the high bound to 2, and put the translate y to 0. So now when we adjust the curvature, we get this kind of thing happening. And then we also want to adjust the orientation, so we can actually take this rotate value and decide where it is rotating towards. So that is pretty cool. Where did my code go? There we go. Okay. So we know, I mean, basically it is a lot of the similar stuff that we are doing with the squash. So I'm going to copy all of this and just modify it inside of the bend. So this is going to be bend name, bend, and this should be a capital B, just so that I keep my naming convention. This is going to be a bend, and then this is going to be bend name, bend name, this is going to be bend, this is going to be bend, low bound, high bound, and this one is going to be curvature. So let me get curvature really quick. Da, 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 da. Where is it? Where is it? And then we're going to need the value of bend amount. We don't have a value yet, but we'll assign bend amount there. So let's comment this out really quick, and everything else should work really quick. Line 66 has got an error. It's asking for 2 arguments, and we're only giving it 1 bend amount. So let's add to that. Yep. Bend amount. And then I'll copy this, paste it here, and this is going to be called bend amount. We're going to query the value. This is going to be called bend amount. And then I have to go back to the UI and actually create this. And I am going to copy one of these, and I'll put it right underneath the... Actually, I'm going to put it all the way at the bottom. Bend amount. Bend amount. And with the bend, right now I have a min of 1 and 10. Let's do -1 and 1, although that might be wrong. The default value of 0, that is going to be right. Let's see if we get any errors. Line 54. What's going on 54? It's a capital B for bend. No errors. There we go. And it's deleted the history. So there we go. I'm going to turn this back on here. And let's see if we get the bend happening. It's just a very tiny amount. I think it's by degrees of bend. So probably what I need to do is like 45, -45 for the inputs here. So we can go in, where's my UI? There we go. On the bend amount, the minimum value is going to be -45, and the maximum value is going to be 45. Let's try doing this again. So there we go. We get quite a bend. Now we need to do the rotation. Maybe for the label of this is, I'm going to call it tree bend amount, so that way we know that we're working with the whole tree rather than a specific object of the tree. And then gonna copy this. And now instead of bend amount, I'm gonna call this orientation. Let's call this spin. No, that's not really. Let's call this direction. We'll call this tree direction. Tree direction. And this one's definitely by rotation, so I'm going to do negative 180 by 180. Excuse me. And I need to be able to query that. Copy, paste. It's going to be tree direction, tree direction. And that is all good. Tree direction, and then this function needs that as well now. Tree direction, and then we can say mc.set adder, and we are going to want the bend name plus dot ry. That is going to be equal to the tree direction. Cool. So if we add a bend, we should be able to see it bend, and as we adjust this, we can get the rotation. So if we go to either end, it should be at the same point, but it will rotate itself around there. There we go. And it should still do everything else that we want. We should be able to get the height and add a little bit of stretch. And we can do all these things with the trunk right now. Yeah. We have a pretty good working trunk. Let's add one more thing to the overall tree that I think would be kind of cool, is a twist. And maybe we can do it with the individual trunk. And then as the tree as a whole, we can try that. I'm just going to do the tree as a whole. We can do both. It's fast. AP twist obj. Tree grp twist amount. And that is all I need right now. Okay, so we have that. Let's create a element inside of the GUI. So I'm going to copy this, paste it, and this is going to be tree twist. Tree twist. And then we're going to do, I don't know what the min and max values are. I'm going to leave it at negative 180 and 80 because it might be rotation. That would make sense. And then, so this is called tree twist. We need to be able to query it down here in the tree gen. I'm going to copy this. But this is all going to be based around tree twist. And tree twist. And I named it twist amount, so let's just call this tree twist. And I'm going to define obj, AP obj, or AP twist obj. And now that I have that twist function, it's basically going to be the same thing as the bend. And let's see when we add a twist here really quick. It's going to be under deform, nonlinear, twist. It is of type twist. We have the twist handle, it's lowercase t, and let's see inside of the inputs what we are going to be doing. The low bound, high bounds, we know we're going to change those. And then start twist angle and end twist angle. And I believe we'll probably just do the end because I want to be able to control the top only. Actually, that's kind of cool. So if I have that like that, that's actually giving me the result that I want. I might not need to change the low bound because if I change this, it's only going to twist the top part. Not the start angle, but the end angle. Yeah, so I'm going to leave this, what was it, a -1? I'm going to leave that all the same, and I'm just going to adjust the start angle. Okay, so this is going to be twist, twist, twist. Let me twist, twist. And instead of bend name, I say twist name. Copy and paste that. there. Twist amount. Actually, we don't need this attribute anymore because we are not going to be spinning this at all. We don't need to adjust these things at all. And instead of curvature, we're going to do the end angle, and that is going to be based off of the twist amount. We have an error in line 81. Let's check that. It says takes exactly 1 and 2 are given. So here we need obj name. There we go. 67. Bend name. So I'm still using bend name, and this should be twist name. There we go. So if make this taller and stretch it and add a bend to it so that we can see the twist happening. That is cool. We have a twist amount, and we can twist it in the opposite direction as well, I believe. Yep. That way or that way. Cool. So if we wanted to, we can do this in the trunk and already have some of the attributes that we can use the same function again. So let's look at using that double functionality. So let's go in and check we'll add another attribute here. And where do I want to add it? I'm going to add it kind of after the height. I want the twist to happen the very first thing. Instead of tree twist, I'm going to call this trunk twist. Trunk twist. And that should be everything that I want to adjust on there. This time I'm going to query it in the create trunk because I don't need this on the global level. Oops. There we go. And then instead of trunk squash, we're going to say trunk twist. Trunk twist. Label trunk twist, trunk twist. Cool. I think we have that all set. And then let's create a function after we create the actually, we're just going to call the same function that we have here that we've already created. So this time the obj name is going to be tree trunk. And the twist amount is going to be the trunk twist. And with very little work, we should see that with the trunk twist now, basically what it will do is kind of make this spiral on the trunk itself. So as we increase the height, you can see that it still has that twist, and we can bend it and we can twist the whole tree, but it still has that twisty nature to it. So we're using the same function, but to do something a little bit different. All right, so for right now, I think we're going to split this off. So this is going to be part one of this tool. We can see we've written quite a bit of code. We have, 89 lines of code right now. But we need to make the trees and branches and all that stuff still. But for right now, I'm going to leave this where it is right now, and then we will figure those out in the next tutorial for this series of videos. Alright, I hope you guys found this useful. If you have, please like, share, and subscribe. It helps me out a ton. Hit that like button, and we'll see you guys in the next video. Bye!